So now that we know about significant figures, we can move on to linear motion. So when we're talking about linear motion, we're talking about motion in a single direction at a constant speed. We only have one equation, and that equation is the following: x equals v times t. That is our first big physics equation. It's actually a pretty easy equation. So what do each of these things mean? So as we had talked about before, x is a distance. So x is a distance. V is a speed. And we use the letter v because of velocity. So we call it speed or velocity for now. And t is the time. Right? So when we're talking about distance, in order to put it into this equation, we're not talking about where it started or where it ended. What we care about is how much the person moved. So to visualize this, it helps to draw a number line. So let me draw a number line. So this is a number line that goes from 0 to 10 meters. Right? So 0 meters, 10 meters, and we have 2, 4, 6, 8, and 10. Sorry for the perfectionism. Okay, so we might have a person who starts at 0 and moves all the way to 8. So from 0 to 8, their distance is 8 meters. But some other person might not start at 0. A person might start at 4 and end at 8 also. So even though they both finished at 8, this person went from 4 to 8, which means his distance was 4 meters. So when we talk about distance, remember to not put the initial point, not put the final point, just put that difference. How much a person moved from their starting point to their ending point, no matter where it was. So that's distance. And something that we care about a lot in physics that we already covered a little bit last class is units. So I'm going to tell you the units of each of these quantities. So for distance, when we talked about SI units, we learned that the SI unit of distance is the meter. So that's the one we're going to use in most exercises and most examples. But there are many other units that are also distance. So you might also find kilometers, you might find centimeters, you might find miles, which is written as MI, because only M is meters. We also have yards, we also have feet, etc. But what we care about the most is meters. For speed, so speed is, as we saw, in meters per second in SI units. But we also hear a lot about kilometers per hour. That's what our cars measure speed in. And in the US, they measure in miles per hour, which is written like this, mph. So the P stands for per, but just means miles in every hour. We might also get, centimeters per second or inches. I missed inches here, inches per minute. There are many, many possible units, but again, the most common are meters per second and kilometers per hour. And the only SI unit is meters per second. And in time, we have our normal units of time, which are seconds, minutes, and hours. Always remember to put numbers with their respective units. So now let's see how we could use this equation. So I'm going to give you an example exercise, and I'm going to erase here. Suppose that a girl moves from her house to the store, and it takes her 10 minutes. And she was always maintaining a speed of 5 meters per minute. So she was walking pretty slowly. And my question is, how far away is the store? So what is X? So first we have to identify what we're given in the problem. We can use the units for that. So if it took her 10 minutes, and we know that minutes is a unit of time, we know that this value over here is our t. And this value is in meters per minute, which the only quantity that has a division in the units is speed. And it has a division of a distance over a time. So we know that this is our speed or velocity, v. And we're looking for x. So we go back to our equation, x equals vt, v times t, and we plug our values in. So v is 5 meters per minute. And remember, we can use the dimensional analysis that we learned last class, times t, which is 10 minutes. So here we can now see that minutes and minutes are going to cancel out. Minutes cancels with minutes, and our answer is 5 times 10, which is 50. And the only unit that we have left is meters, which is correct because meters is a unit of distance. So that gives us our answer. The store is 50 meters away from the girl's house. Now, what if instead of getting v and t in the problem, we get maybe x and v, and we're asked for t? So one way to do this is to solve the equation for the variable that we're looking for from the beginning and know what they are. So let me see. So we have one equation, which is the way in which it's normally written, which is x equals vt. Now, if we want to look for v, we're going to leave v on that side, and we want to divide x over t. So pass it to divide to the other side. So we get this, v equals x over t. If instead we wanted t, we would pass v to divide. So we get t equals x over v. So what some people like to do is to just memorize this one and do the algebra every time to solve for v or to solve for t. That's personally the way in which I prefer to do it, because I'm not very good at memorization. So I just prefer to know one equation and then do the quick algebra to find the equation that I need. Some people prefer to memorize the 3 equations, so they can remember the 3 equations always. And another method that I'm going to teach you is one that I actually learned from my students last year, and they told me it helped them a lot. So I'd never use it, but maybe it helps you, and it's something you can use. So what they use with these types of equations that have one thing on one side and 2 on the other is they draw a triangle. And they put a line in the middle, and they divide the bottom into 2. And they write the equation inside of the triangle. So they put the thing that is on one side alone goes on top. In this case, x. And then the bottom we put v on one side and t on the other. So the way to use this triangle is that you cover the letter that you're looking for, and you will see what you need to do with the other 2. So for example, we're looking for x. So we cover x, and we see that v is beside the t, so they multiply. So we would get the equation x equals vt, which is this one. Now what if you wanted v? So you cover v, and you see that x is above t. So that's the equation for v. v is x above t. And the same with t. If you're looking for t, you cover t, and you see that x is above v. So that means that you divide x over v. And that gives you these 2 equations. So if you want to memorize one and find the others algebraically, that's fine. If you want to memorize the 3 of them, that's fine. And if you want to use the triangle, that's fine too. So whatever method works for you best, that's a method you can use. A quick reminder about units. So suppose you're solving a problem and you want to find v. So let's use our equation for v is x over t. And they tell you, okay, x is, so you calculate, x is 30 kilometers and t is 5 hours, right? So you want to find the speed, and you do 30 over 5 and you get 6. This is 6, And the unit will be the unit of the distance over the unit of speed that you used. So that would be 6 kilometers per hour. What if they instead told you 30 meters in 5 minutes? So your math is going to be the same. 30 over 5 still gives a 6, but now your unit is meters per minute. If you put it in kilometers per hour, you're going to get it wrong. What if you get, let's say, 30 miles in 5 hours? Then you're going to get 6 miles per hour. So always take into account the units that you're given to figure out the units that your answer is going to be in. If not, you're going to get it wrong. So you're going to need that for one of the exercises that we're going to use today, that you're going to need to find the number and the unit. And you find the unit from the question itself. Okay, and now finally, let me erase these examples. There's one last equation that is sort of, it's like this one. So we have the equation v equals x over t. But something you might find a lot is something called average speed. So average speed, which is basically v, but an average is the total distance. So what we have on the top, our x, is total distance of a trip over the total time. So some people get confused with this equation, but I'm going to do a simple example and I hope it makes it clear. So let's say that you want to travel from Bogota to Barranquilla. So Bogota is somewhere over here in the middle of our beautiful country, which I don't know how to draw, and you want to go to Barranquilla. So it's this. And the distance between Bogota and Barranquilla, so between Bogota and Barranquilla, there are 1,000 kilometers. This is the truth. It's an actual value. 1,000 kilometers in driving. And how long does it take you? Well, some people stop 3 times to go to the bathroom, to eat lunch, to eat breakfast. Some people stop only 1 time. Some people stop 5 times. Maybe for one family, the total time it took is 17 hours. Wait, sorry. 17 hours. So if we want to know their average speed, we would just put these 2 values. So their average speed, I'm going to write it as average speed, is the total distance of 1,000 kilometers over the total time of 17 hours. And that gives us 1,000 over 17. That gives 58.8. But remember, we have 2 significant figures, so we approximate that to 59 kilometers per hour. So you could say, that's so little. I mean, I usually drive, or my parents drive, at almost 100 in the freeway between Bogota and Barranquilla. Why would the average speed be so low? And that's because in the average speed, you take into account the stops too. This 17 hours includes the 30 minutes that you were having breakfast, the hour that you were having lunch, the 20 minutes when you stopped to watch the mountains or whatever, the place entering Barranquilla where it was very heavy traffic, and the moments when you were driving at 100 kilometers per hour. So average speed, you have to include everything, even the time that you weren't moving.